All right, let's start. So a quick recap of all the tests that we had seen yesterday. So can you please help me out? What all we have learned? What all statistical tests we have learned? Yes? Okay, so let's begin with hypothesis testing. And hypothesis testing has two things. One is null hypothesis, and you have alternative hypothesis, right? So as a part of hypothesis testing, we have some stats test, right, which depends on the data and business problem. What are you trying to prove, right? That's your stats test. So once you decide on your stats test, you also decide on your alpha. What percentage of errors are you trying to allow in your system? Are you trying to allow 10% errors, or are you going to allow 5% errors, or are you going to allow 1% of errors? Using error is a very wrong word here. Just to give you the perspective, I'm using the word error, but it is known as confidence intervals, or alpha is known as 1 minus confidence interval, right? If any of the value, any of the score lies in this region of the histogram, any distribution, depending on the test that we are doing, right? So then what happens? The null hypothesis gets rejected if it is in this alpha region. Alpha is also known as rejection region. That region where you will definitely reject your null hypothesis. I hope that's clear to all, right? Yes, sir. Alpha is known as rejection region. Confidence interval is known as acceptance region. Is that clear? Yes to all? All right. Online guys, I hope this concept is clear, right? This is what we have seen yesterday, isn't it? Yes? Okay. Now, once you have decided your alpha and the stats test, you will try to get the test score. This also depends on type of test that we are doing. Depends on the type of test that we do, right? So we have got Z and T tests, we have F test, we have chi-square, right? So these are the basic stats tests. There can be a lot of other tests here. Like for example, I have something called Shapiro-Wilkes test, or a little bit improved version of Shapiro-Wilkes test is Anderson-Darling test. So these are some of the additional tests that we have in stats, which we might come across, at least theoretically, not in depth, right? So for all these tests, we have null hypothesis and alternative hypothesis, right? Now, null hypothesis always checks for equality. I mean, like, just remember it. I mean, like, this is not the official definition, but just remember it in this way. If you think about an equal to sign, then you have to think about null hypothesis. I'm so sorry, it's the other way around. Whenever you're thinking about null hypothesis, always think about equality. It's not about the problem. Null hypothesis doesn't mean that it's a statement that agrees to your problem. No, sir. Null hypothesis is a statement which always shows equality, right? Alternative hypothesis checks for inequality, or it checks if less than, or checks if greater than. Never equal to. It's never greater than equal to, it's never less than equal to. It's either greater than or less than, or simply not equals to. And this one is always equals to, Remember that always, right? And also, just to give you perspective, the t-test and z-test, what we have discussed, the success of that test depends on the acceptance of null hypothesis. I hope that is clear by now, right? But there are some tests whose success depends on rejection of null hypothesis. So it all depends. So null hypothesis is not all about the statement that you're trying to prove. No, null hypothesis is always about equality. This is one of the biggest confusion that non-stats people have. If you have studied statistics before, so this will not be an issue at all. But all the non-statistics people, they have this confusion. So always remember it like this, right? Now your test score depends on type of test that we do. So we have this p-value which is given by the software, given by the stats tool. P-value stands for probability value, right? A low p-value denotes lesser probability of accepting null hypothesis. Is that clear? A low p-value denotes lesser probability of accepting null hypothesis. That's the statement. But also you have to check like this. P-value, if it is less than alpha, then what will we do? Reject null. If p-value is less than alpha, reject null. Sometimes you also accept null on the borderline cases. Or accept or reject null on the borderline cases. Let's say your alpha is 0.05 and your p-value comes up to 0.04. That's a borderline case of rejection. So statistically you have rejected your null hypothesis, but if you dig deeper into the business problem, there is a lot of subjectivity that gets involved here. So you might forcibly accept null hypothesis in that case based on your business problem. See, one thing, please keep it in your mind moving forward. All the things that we do in statistics is highly subjective. Your stats might say something, but your business logic would talk otherwise. So there has to be a balance of both the things. A simple example, like if we just run a linear regression or a logistic regression, let's say, logistic and linear both, and just try to see should we increase the course fees or not. And if we are increasing it, by how much percentage we should increase it. Let's say the entire statistical system says yes, increase your course fees by let's say 10%. Sorry, by let's say 15%. Now 15% hike in the fees is a little bit too much to take in the competitive market. Yes or no? Especially given the number of similar kind of institutes coming up. So that will be a small problem for us if we are not competitively priced. So my statistical system might say, hey, to have good profits next fiscal, increase your fees. But my business logic says, hey, watch it. If you are increasing the fees, there are chances that you might let go some of your prospects. I hope you're able to understand what I'm saying, right? So there has to be a perfect balance between your business and statistics. So one suggestion I would give you one suggestion I would give you, people who are good with your business logic, like people who have studied business administration, masters or bachelors or anything. So you have that advantage of knowing a business in and out. The only way which you have to improve is your mathematical skills and coding skills. If you don't have that already, maths plus coding skills is what you have to improve. People who have done statistics, they must really work hard to improve their coding skills and business skills, right? And I have got no advices for the BTech people. We are versatile, right? And on a serious note, people who know coding, for the technical background people, BTech, CSC, or any branch of BTech, we seriously have to work on business aspects and statistical aspects. This is where if you're falling under that bracket, you have to focus on these two things, right? You might be good at your Java, you might be good at your coding, and all the stuff that's given. It's okay. You can do good ML, but that is not worth at all if you don't know statistical research and if you don't know the business aspects of it. So we have to develop that. Now coming back to the topic, a low p-value denotes lesser probability of accepting null hypothesis. So that's why they have this statement like if p is low, null will go. Just remember this phrase, right? All right, so this is all about your hypothesis testing. So yesterday we had discussed why. All right, okay. I gave that advice. All right. So now coming to z-test and t-test both, what are we testing in this? We're trying to prove if sample mean equal to population mean. This is a very simplistic definition. A very simplistic definition of z-test and t-test. So first things first, let's look at z-test. So z-test, number one, applicable if the data is normally and more preferably works especially on z distribution. And what is a z distribution? Z distribution is otherwise known as standard normal distribution. The entire scaling is on standard normal distribution. Prerna, just give me a second. I'll give you a chance to speak. Is that clear? Next, I think if I had skipped this point yesterday, I'm so sorry. Please take a note of it. Right? Next, we have a good sample size. We have good sample size. So sample size n is at least greater than 30. Something greater than 30. Yeah, this is a correction on z-test. I think I had said any distribution on t-test, but that also I'll correct. Just give me a moment. Here we have the population information. We have the population information, right? And by population information, what do I mean? Population is normally distributed. That is a condition. So that's agreeing with the first condition, right? We know the mean, and yes, we know the standard deviation, right? Sometimes this mean is known as, sometimes this mean can be exact one. Sometimes this mean can have interval. That interval is denoted by standard deviation, of course. Yes, this is what I'm saying. Sometimes this mean will be hypothetical mean. Hypothetical mean, let's say for example, if you're looking at the population of this country and you're doing something with the population of this country as a different organization. So the population of the country has been extrapolated again by sampling, but it is that research is done by some other organization. That's the government of India, which has done the population survey, right? It gave you that figure that India has 1.2 billion people. That information you already have. So that's a hypothetical value. Is that clear? That's a proven hypothetical value. So that can also be your population information. Or sex ratio is your population information. Let's say you want to do your own market research. You will depend on some existing data, isn't it? So sex ratio is a existing data which is given to you by some other organization, by some other research. So your mean can also be that. I mean, like in case if you are wondering, like how do we know population information? So this is how you know population information. Either you calculate your own population information or you get it from some other external sources. So that's called hypothetical mean. And of course, we know the standard deviation. So that's the places when we can do z-test. Right? That's the first WH question. Next WH question is what to calculate. What did we calculate? We calculated z-score. And here is the formula for z-score. I'm just copying this here. This is your z-score. Is that clear? Now that was your z-test, and based on this z-score, you will see if this z-score is lying within the acceptance region or outside the acceptance region, or it is lying in the rejection region, depending on your alpha that you have chosen, right? Because after this, the next step is choosing alpha, isn't it? So looking at the probability that this z-score is proper, you'll have to look at your alpha, right? We have seen that Melbourne petrol price example, right? All right. Now, hey, one thing, the reason why I had gone in depth with Z and T test is because you first have to understand how hypothesis testing is performed in the first place. Because this p-value is something which will keep appearing in everything that we do from now onwards. And you must clearly understand what p-value is saying, and I hope everyone in this class has understood what is a p-value, isn't it? Yes? Is that a yes? Online guys, how about you? A little. Well, that I would say an honest answer. Uttam, yes. Again, every one of you, I just take it as a correction. So population and the sample all must be normally distributed. This entire z-test works on normally distributed data. Yes, Prerna, please go ahead with your question.
So, Sunit, according to, so you're saying...
One second. Just please speak a little bit louder.
Okay, so for z-test, the basic rule is that the n should be greater than 30, right? And by CLT, it implies that if the n is greater than 30 sample size, it will be normally distributed, right?
No. CLT never says that. I have just taken that as an example to explain you. Like 30 I have taken here because I know from previous things that 30 is a good sample size, that's it. Even if I take 15 and I take good enough multiple samples, then still the entire distribution will be normally distributed. For the entire means, the distribution will be still normal.
Okay.
So this is what is the basic idea of CLT, right?
Yeah. So
the samples that you take, more the means you collect, all these means would be normally distributed, no matter whatever is the distribution of the population.
Okay, so by now today you're saying to perform...
Like for example, I have given you this example, right? So I called a petrol pump, one single petrol pump. There are no 30 values there, right? You're getting one value, that's it, that's enough.
That's a
Likewise, you collected information from 50 petrol pumps. Or there can be a situation where one source will give you a lot of inputs. Like the rice shop example that I've given you. One shop might give you 30, the other one might give you 15, the other one might give you 50. So likewise, you collect information from 50 shops. So here you're doing it in two steps. One shop you're collecting 30, you're calculating mean. So that's the rice shop example. For the petrol pump example, one petrol pump you're asking the price, you're just taking it as the mean, hypothesized value of mean, one single value or exact value of mean. I hope you're able to understand that now, right, Prerna?
Yeah. So what you're saying today is, I mean, this is different from yesterday, that both the sample and the population has to be normally distributed for z-test.
Yeah, that's what it is. But even yesterday I had told you, right, the sample is normally distributed as well.
Yeah. Okay. And what do you exactly mean by hypothesized mean? So hypothesized mean you said in t-test.
As in, like, see, one single value which has been proven by some, that's what I said in the morning, right? What do you mean by hypothesized mean? Like, let's say the population of this country, you don't get the population of this country by counting each and every head. That is also being done by some research, right? Yes or no, Prerna?
Yes.
So that is what I'll call it as hypothesized mean. So someone else has estimated that for me, and I'm using their estimations. That's it.
So how is it different from the...
Nothing, it's not different.
No, like, I'm saying
on the other, you have your value, that's it.
I'm saying
no difference over there. So your mean can be any one of these three values. So should I say this as which source your mean has come from? Exact mean or an interval mean, or some hypothesized value which comes from some other research. Maybe these two are the ones which you have found it out on your own. Like let's say you are doing your own market research and you wanted to find out the annual household income of each and everyone in Bangalore. So you have your overall GDP, per capita income, but still you are not relying on that figure. You wanted to do your own research. Then you can get your own value. Is that clear?
Okay. Okay, so I mean it's the mean for the entire population, even if hypothesized, and if I compare it with the shoe industry example that you gave yesterday, right? That was also a hypothesized mean of the population, correct?
The t-test example, that is what are you talking about?
Yeah.
So this one, right?
Yeah.
Yes, exactly. So what these workers did, these workers took 15 people and they took their salaries, and the mean came up to be 670.
Yeah.
So they are telling that 670 is the population mean. So that is what they are hypothesizing it.
630 was the population.
670, sorry. 630 was never the population mean. I have mentioned that clearly, right?
Yeah. Okay.
I hope.
I got it.
Yeah.
Yeah.
So what these workers are saying that, hey, I have took a sample of 15 people, and so this is what is the mean that I have got. So this is the population mean. This is what they are claiming. I mean, like for 15 people's salary, they're saying that everyone receives this kind of a salary, right?
Yeah. So 630. I mean was.
Oh, forget 630. I mean, like, don't get into the 630.
Okay.
630 is something these people are receiving. 630 was never a population, this thing. Now, if you ask why are we checking with 630 here? So we are checking with 630 here because we are saying that 630, whatever salary we are giving, this is equal to whatever population mean we have. We don't know the population mean yet, right? This is what is the entire meaning of t-test. We don't have the population information, right? So we are just trying to prove, in my terms, 630 is something which everyone receives. This is in my view, because I'm giving you 630, because even I would have also done a research, right? I would have also done a research, isn't it? So my research says 630 is the population mean. So I'm just checking what is the actual population mean. Is it equal to whatever I'm claiming at 630? But anyways, I'll come to this example. Give me a moment. You just mixed up everything. Let me come to this one by one, shall we? Right? Prerna, I hope your question is clear, right? Yeah, your doubts are clear, right? Okay. Now, so we calculate z-score and we move on and we just try to see if my sample mean equal to population mean or not, right? So this is all about z-test. When do we do t-test then? When do we do t-test? Yes. Now, this we don't know. Distribution of data is unknown. Distribution of, okay, I'll come to that population. Distribution of sample is a t distribution. Distribution of the sample is a t distribution. There are certain tests to prove if your sample is t distributed or not, but I'm not getting into that complexity. But I think I have explained you how a t distribution looks like. It doesn't look like your perfect bell curve, but just imagine if your bell curve has less variance or your bell curve has high variance. So just look at this. If this is your mean, you can have a curve which has very high variance. By high variance means high variety, but it doesn't have a strong mean. So it looks like this. high variety of data. Yes, there is a good extent, but very little data points and very little mean, right? Or you can also have a situation where you can have good enough mean, but very little variety, right? These are some of the examples of t-distributions. And usually this point comes in where you have lesser sample size. That's it. That's the dots where everything gets connected. You have less sample, you might end up having less variety in your data. Or you might have taken a sample which is totally biased, so hence you have a lot of variety in your data, right? So this is your t-distribution, at least theoretically. Now you have a lot of tests to prove your t-distribution, but again, like I'm saying, we're not getting into that complexity, right? We're not getting into that thing. For t-test, we don't have good sample size. N is less than 30. And we don't have the population information. We don't have the population information. So if you look at the t-test example again that I had given you, the worker's salary, I never said the worker's salary is normally distributed, did I? Was there any sentence which says that worker's salary was normally distributed? No, right? But in the Melbourne example, I had definitely said that petrol prices in Melbourne are normally distributed, right?
So t-test is always compared between two samples.
Yes, of course, right? I'll come to that again. I mean, not just that, there are varieties of t-tests that I had discussed during the end of yesterday's class. I'll come to that once again. Now, we don't have the population information. We don't know the distribution. Distribution is unknown. We don't know the mean. Yes, but we assume some value to be the mean. We assume some value to the population mean in some cases, and we check if our actual population mean is equal to our assumed population mean or not. I mean, like, this is one statement which I'm giving totally off the track. I mean, like, that's something which you don't. I mean, like, it's not a proper definition, should I say? But just to give you a perspective, I'm giving you the statement, right? So, like yesterday's example we have seen, or maybe like, just give me 2 minutes, I'll come to that example, the workers example, right? And we don't know the standard deviation. We don't know the standard deviation. Let me just add this word, population, right? So this is when we do t-test. So what do we calculate? We calculate the t-score. So I'm going to copy that t-score formula here. So just look at the way how z-score and t-score are changing. So just look at this, please. See this value here? This is our assumed value, hypothesized or assumed value. Is that clear? So in our example of workers, again to repeat this example, the workers claim that 670, which they have found out, the sample mean, is the actual representative of population. Hence they are concluding that they are being less paid. Now as a management, we are performing a statistical test and we are saying that, hey, the sample mean is 670, fantastic. But in my mind, the actual mean is 630 because I am the management and this is what I know. I'll not get into your assumption of 670. I'm taking my assumption of 630. So that's my hypothesized value of your population. So 670 minus 630. So this is what we had done yesterday, right? We are assuming that 630 is the population mean because we are the management, right? 670 is the sample mean, simple. I mean, like, according to us, 670 is not a representative of population. It's just a mere sample mean, which these people have given. These people have given me. I hope you're able to understand that, right? And we have our standard deviation of sample, some 58 something, divided by square root of 15. 15 is the sample size. And we calculate our t-score. Right? Is it clear? Yes, you can also say that, Siddharth. That's correct to some extent. Yes, maybe. Let's look at the next thing, like what kind of t-tests that we do. Maybe yours and your doubts will be clear. So t-test or z-test in general, we have the following cases. So one sample t-test. One sample t-test. I'll be using the word t-test because it is more general. It's more generic. T becomes z if these conditions are met. But until then, everything is a t-test, right? So one sample t-test. What do we do here in one sample t-test? We have a sample and a value that is assumed to be the population mean. Is that clear? That's your one sample t-test. Is that clear? Online guys? Siddharth, I hope your doubt is clear, right? Your question is clear? And how about rest of the people? I hope one sample t-test, this is clear to all, right? Hello?
Sir, this Z-score, T-score can be negative also, or we should take all considered?
Yes, they can be negative. Because if it comes under the other side, left side of the mean, it can come negative, right? So here, yeah, 670 minus 630 is a positive value. Let's say this is 600, for example. So then it's a negative value. But in any case, like it all depends on what alpha, what kind of what do you say? Not test. What do you say? What kind of alternative hypothesis you have chosen? Is it a one tail or two tail? So usually, if it is one tail left hand side, that will be negative. Two tail, that will obviously be negative, right? I mean, there is a chance of getting a negative value. In case we have two statements based on less than 30 samples for alternative hypothesis. In case we have, that's a two sample t-test. I'll come to that. Siddharth, just hold on, just hold on. We have this two sample t-test. So we have got two samples and we check if their means are equal or not. One case study that I will be taking that will give you a very good perspective of two sample t-test. You have got two samples of same kind of people. Like I've taken 200 people, right? And I have two samples of the same metric. And I'll try to see if these things are matching or not, right? I'll explain that example later. So once I explain that example, maybe this two sample t-test will give you a perspective. Next up, I have independent sample t-test. So still I have got two samples and I'm checking if the means are same or not, but only addition is two samples that are mutually exclusive. They're mutually exclusive, they're independent of each other. Then we are trying to prove if their behavioral pattern is same or not. Male and female as a group, both are completely different. It has been known that both exhibit different behaviors for different products. Yes or no? But still we'll try to prove if their perception of a certain product or a service is same or not. how do they use mobile services? How do they use data services? How do they use credit card? Or how is the behavior when it comes to buying garments? This garments example is one thing where both the means might be different, right? Let's say an average spent by a female per month on garments could be on a higher note than the male, could be in my population, in my sample. I can say that, isn't it? So both are mutually independent groups, right? So that's your independent sample t-test. Siddharth, right? Siddharth, yeah, please go ahead with your doubt. Siddharth, please.
Hi, can you hear?
Yeah. Pardon?
Hi, hello.
Yeah, Siddharth,
can you
I can hear you. I can hear you. Please tell me.
So my doubt was like,
Siddharth, I'm so sorry, like your voice is cracking up.
we were discussing there are 3 types of t-tests. So basically, you see, if
Better now?
I was saying, so in t-test, we are checking if the sample we have is significant.
Siddharth, 1 second. Siddharth, I'm so sorry, like your voice is cracking up. No, Siddharth, I'm not able to. By the way, rest of the online guys, are you all able to hear me?
Okay. Is that
Siddharth, I should stop you here. Maybe you can just type your question in. I'll just give you 2 minutes. I will not.
I write it?
Yeah, write it. Take your time. Write it. I'll pause for 2 minutes. Yeah. Yes, Uttam, go ahead.
Yeah. Okay. I'm trying to understand what you said yesterday and what you're saying today. I think there are 2 different things. One is the central limit theorem, which says.
1 second. Why are you involving central limit theorem in this? Did I say anything?
No. I'll tell you where I'm going with this.
Okay.
Basically, that says that if you take a samples or multiple samples, they will be normally distributed. Yes, that is
No. I never said samples will be normally distributed. Did I say that, guys?
The means of the samples.
Yes, exactly. The means of the samples will be normally
distributed. And from there, you get this concept called the standard error of the mean, which we use, with standard deviation divided by square root of
sample
population, right? which we get. Now, the second part of it is the z-test and t-test. Now, for the z-test and t-test to be used, you're telling us that the population mean must be normally distributed.
Yes.
And so must the sample that we take.
So
okay. And similarly for t-test, now you're telling us that the population does not have to be normally distributed, or we don't know the distribution.
We don't know the distribution.
Therefore, it could be anything.
It could be anything, yes.
And our sample must be normally distributed or not necessarily normally distributed?
No, distribution of the sample is a t-distribution actually. I told this yesterday, right?
So t-distribution is basically a normal distribution with the tails being a little higher up or whatever it is.
So this is never called a normal distribution in the first place. Just because it is looking like a bell curve, doesn't see. Okay, let me give you one more perspective. 1 second. Let me give you one more perspective. This can also be a t-distribution. Is this a normal distribution?
I see. What if it's the other way around? That is, let us say it's an exponentially increasing curve.
So it's an exponential distribution in that case then. So
the exponential distribution is exponentially decreasing.
See, one thing. Again, I'm saying, like, if you have a very little sample size,
yeah.
So not just normal distribution, any distribution is not so clear about it. I mean, like, let's say you have like 20 continuous values.
Okay.
You're having 20 values, isn't it?
Okay.
You can't. I mean, like, most of the tests would fail. Like for example, if I'm just trying to prove if I have 28 or 25 elements, if I'm trying to run a Shapiro-Wilk test to prove that it is normal or not,
That
test will definitely be a little bit biased.
Okay, let me give you an example of something that I saw.
Let me complete. May I?
Yeah, go ahead.
So t-distribution is something which is highly applicable on smaller samples. Either you have taken a sample which might be a little bit biased and where you have got high variety of information. So that red curve is something which is showing a high variety of information. This curve can also be like this. Let me do a freehand drawing of that, represented by this pink line. High variety of data can be like this as well. One second. This can also be a high variety data.
Sure.
It's nowhere near normal as well. I mean, like, at least like if you look at this red line, you might have one thing in your mind that, hey, this can be made normal. I mean, like, this looks normal, but this is not normal. Neither the red line nor the pink line, both are not normal.
Okay.
And they are just another sample, lesser size, and you don't know how it looks like, how it might look like.
Okay,
You're not again sure about its proper distribution. So I would say it's a t-distributed value.
Can I give you another example which I actually bumped into? I was reading it somewhere. Let's assume the distribution of marks in a class. The maximum is 100, minimum is 0, and people typically get between 50 and 100.
People typically get between 50 and 100.
So there are very few. Maybe there are 2 or 3 that got 20, 30. Everybody is between 50 and 100. So you'll have a curve that is literally exponentially increasing up to 100.
Okay. You mean like this?
It'll be something like that. Now, is that any kind of distribution that can be used?
So, see, I wouldn't call this as an exponential distribution, first of all.
Oh, I see. Okay.
This is just a simple scatter plot, maybe. One second. So, how are we drawing this plot? What are we taking on y-axis?
Y-axis is the marks.
And x-axis is students.
X-axis students, yeah, students.
Students and their scores, right?
Their scores, yes.
So this doesn't come under any of these normal or t-distributions.
Okay.
Maybe, like if I have, for example, let's look at it like this. Let's say in a class, let's say we don't have 40. Okay, even if we have 40, this might lead up to a exponential distribution. Might be, if whatever you are saying is the condition, like there are 50 people, or let's say there are 40 people, and there are many people who scored marks from within 60 to
100,
say 80, or 60 to 95, for example.
Okay.
This can be the ideal scenario, right?
Right.
There can be few people who scored, okay, why 560? Let's make it 50 to 95.
Fine.
There might be very few people who might have scored like 30s and 20s. And there might be 1 or 2 people who might have scored like 96, 97. There are, yes. So, that case, if you call this exponential, yes, it can. If the distribution is exponential or not, that we have to prove it later. I can't call it without statistically proving it. I can't call it exponentially distributed. Even for normal distribution, without statistically proving it, I can't call it as a normal distribution. I'll have to check a lot of factors. Like, let's say in linear regression, the very first point that we will learn is, my very first assumption or my very first condition of linear regression is my dependent variable is normally distributed. To prove it, there are a lot of things that we will be doing it, right? So just to conclude that this is exponentially distributed, I have to prove a lot of stuff. Is that clear, everyone?
Yeah.
And Uttam?
Yes.
So T-curves, Prerna, I would say like, I wouldn't comment on symmetry, but because not every time a T-curve would be symmetrical. That's not guaranteed, I guess. Yes? But you're right about it. They are not the ideal bell-shaped. Like, let's say, for example, we know that let's take this Melbourne petrol price example. It says the actual population is normally distributed, right? Now you take, instead of taking 50 samples, let's say you have taken 10 samples. You might get a graph which is like this yellow or this red one. I hope you're able to get it, right? You might get a graph which is close to this yellow one because your original data is symmetric. Maybe the sample might be symmetric. We don't know. We don't know how we'll end up with this, right? I hope that's clear now. And coming to Siddharth's doubt, in t-test we check whether a sample is significant enough to attack a null hypothesis. And so we see using this closeness of means. I think understand it now. So I hope you have understood it, right? Siddharth? Okay. So I hope this entire t-test and z-test thing is clear. Maybe like if you can just look at a case study, we'll clearly understand. Like if you can just sit and solve along with me, sit and write a code along with me, you'll try to understand how this is done, right? All right. Now let's look at this independent sample t-test. Everyone, please look at this. In independent sample t-test, what did I say? What do we do here? I have given this typical example, male versus female, right? So let's say in a sample of, let's say I have 100 males and 100 females. Just for simplicity sake, I'm taking 100 and 100, equal number of males and equal number of females. Just to explain you, that's it. So you'll take your average spent of male and average spent of female. If you're looking at, let's say, expenses, or if you're looking at credit card spent, or let's say amount spent by each gender on purchasing certain mobile packs, right? I hope I'm able to explain you this, right? So you will do this as if you're doing a 2-sample test. You will do it as if you're doing a 2-sample test, but only thing is you have got 2 mutually exclusive groups. Clear? Now, let's say this was with gender. What if I have something called region or customer segments? I've got 3 segments of customers now. I have got silver. Let's say I've got gold, I've got platinum, and I've got 10,000 people. Let's say your challenge is to put these people in these buckets. It's based on the spends. That's one example. Other example, let me tell you. Let's say there is Uber or any taxi service, let's say Uber or Ola. So they want to give some discounts. Everyone please listen to this example clearly. They want to give certain discounts. They say like if average monthly spend by a certain customer is 1,000 rupees, if a particular customer on an average in an entire month he spends 1,000 rupees, he gets a discount of 250 rupees. Right? If someone spends 2,000, they get a discount of 500. If someone spends an amount of 3,000, they get a discount of 700. This is what Uber has decided, as a part of its customer loyalty. Clear? Clear or not? Now, let's see. I'll take group A1 and group A2. So these are the 3 groups that it has decided, A, B, and C. Let's take A1 and A2 for example. I'm taking 10 people randomly, right? Please just look at the values. How many values I have taken? 10. The average is close to 1,000, right? For this group. So I've taken group of customers. And these are their spends, monthly spends. And this entire group average is close to 1,000. So these people deserve a discount of 200. All of these people, because they fall under that bucket, right? Where overall group spend is 1,000 rupees per month. Yes. Yeah, it's okay. Not an issue. I'm not bothered about that. Now let's take this. Here also the average is close to 1000. Yes or no? See, look at this total overall average here. Average is 1010, close to 1000. This group was also having an average of close to 1000, 1007. Yes? Tell me one thing. Out of A1 and A2, these are two separate groups. These are separate customers. I just bucketed them. Right? I've taken bucket A and I've taken bucket B. And I said both deserve a discount of 200. To which extent do you agree? Which group actually deserves a discount of 200? A2? Everyone agrees with that? All of you online guys? Now everyone who is saying A2, can you please explain me, at least in layman's terms, what made you think A2 is a better deserving group for 250 rupees discount and A1 is not? All points are close to the mean. Okay. Any other explanation? Anyone? Online guys this time? So Rajesh, more variance in A2? More variance in A2, I wouldn't agree to that. Again, can anyone else try it? Online guys? Why A2 deserves it, why A1 doesn't? No, Anil, it has nothing to do with normal distribution. Any other guess or anyone else would want to take a try? Prerna, Siddharth? Why do you think A2 deserves a discount of 250 and A1 is not suitable?
So that their average spend is close to the mean.
Yeah, everyone is close to 1000, right?
Yeah.
Even this is also close to this average is also close to 1000.
So every data point
Okay.
There are
So net to net, everyone is saying that in A2, all the points are closer to the
mean.
decided value. That is 1000, right? So 1000 is the mean. All the values are closer to 1000. Here, the values are little bit away from the mean. So what does A1 have and what does A2 doesn't have?
A1 has more variance than A2.
Exactly. So A1 has high variance and A2 has low variance. This is what made you decide that A2 is a better recipient of 250 rupees discount? Yes? Now carry this variance concept and now tell me how should A, B and C differ? So A2, I'll fix it for this one, right? I hope you're able to understand it. Now between A, B and C. So within A, within this group, within all these orange people, I would say that these people should have what? These people should have low variance. Yes or no? These people should have low variance. This is what we have decided here, right? How about variance, the overall variance of A and the overall variance of B and the overall variance of C? How does these variance should look like? What do you think this variance should look like?
They should have high variance within each other groups. A should have high variance with B and C, and B should have high variance with
Fantastic. I couldn't agree more with this.
A and C.
So I hope everyone listened to what Prerna had said, right? So within A, the variance should be low, but across A, B and C, the variance should be high, right? That is what it distinguishes between A, B and C, right? And that is the reason why you said these people will get 250, these people will get 500, and these people will get 700. because most of the points in B are close to 2000 and all the points are far away from 1000, which is group A. Same goes with group C. All the points here are close to 3000 and they are far away from 1000 and 2000. If there is a group D, same rule applied here as well. I hope everyone is able to understand this, online guys. I hope everyone is able to understand this. Yes? Now, let's write it down. Yeah? Variance of A equal to variance of B equal to variance of C, or just copying this here, variance of A not equal to variance of B not equal to variance of C. I hope you're able to understand what I have written here, right? Yes? Which one is a good point in our business example? The second one. Yes? There can be some other example where this is what is needed for your business. It depends on your example that you're looking at. In this example that I'm looking at, the second one holds good, isn't it? Now, here comes the concept of F-test. F-test, we look for difference or similarity between groups. A little bit correction to this. If you are taking running notes, don't take it. We look for the difference or similarity between groups between 3 or more mutually exclusive groups. Is that clear? 3 or more mutually exclusive groups. So that is what is your F-test is. How do we do it? Which factor do we have to look at? Can anyone answer this? Which factor are we looking at? Are we looking at mean? No, we are looking at variance. Variance. Clear? Now, how do you define your null hypothesis of your F-test? I already defined it, but still. Can anyone tell me how to define your null hypothesis for F-test?
So variance of A is not equal to B, not equal.
Null hypothesis, Prerna.
So the variance. Okay, the variance of A is equals to B is equals to.
Yes. So variance of A equal to variance of B equal to variance of C. Is that clear? Right? Okay. Which factor to look at? I said variance. I should actually talk about this thing. Which factor to look at? You look at your measures of dispersion. Measures of dispersion. That is what you have to look at. Right? Measures of dispersion. Variance is one of the most commonly used measures of dispersion. I think this forms a very good textbook example. It's in an interview, they ask you like, hey, do we really have to look for variance? Can't we look at MAD or anything else? You would say, so that's the reason why you can safely say, yes, I can look for any measure of dispersion, but as we all know, variance and standard deviation are the most commonly used measures of dispersion. We would define F-test with a variance. Can it be tweaked later? Yes, it can be tweaked later. Everything can be tweaked later. But those tweaks, let us leave it for future discussions. Right? Because just to give you again a heads up, if you are wondering, if you're thinking in that direction, I'm talking about F-test. There can also be something called pseudo F-test, pseudo F-value, false F-test. So that's what I'm saying. Like, are these the only things to look at? No, there can be some other values as well. And continuing with the same line of questioning, if I ask you like, can I look at means for this? That thing I would say absolutely no. You can't look at means. Means doesn't work here, right? Siddharth, you are 200% correct. Should we consider a controlled variance rather than an equal variance? But then again, like I said, this is your basic F test. The tweaks, they come later. What you said, that also exists, but it is not your F test. It's something else. In which scenarios we will apply this F test? Yes, I will come with a practical example, but I hope everyone understood in which scenario I had used an F test. I have had more than three groups where I have to check whether these groups' behavior is same or not. If I have to check between male and female, it becomes a simple independent sample t-test, right? Because there are only two groups. If there are more than three groups, I can't apply my t-test there. There are a lot of other factors which come in, right? That's when I will go for F-test. Is that clear?
Yeah.
So null hypothesis is variance of A equal to B equal to C. What is your alternative hypothesis? So here there is no chance of tails or anything. You straightforward go for a two-tailed one where you will say these are not equal to or not equal with each other. Is that clear? So this is a null and alternative hypothesis. Now let's calculate our test score. What is our test score? Our test score is our F value, which is a ratio of variance or anything, any dispersion within a group F value is variation within the group. I'm using the word variation, just use the word dispersion or something, right? And variance between the groups, overall variance between the groups. That's your F value. Now, how this F value is derived, how this F value is calculated, that's none of my point of discussion here. Just know that this is your F value. It's a ratio between variance within a group by between the groups, right? Your software will directly give you the F value. Now, how this is calculated and all, you can better ask your stats friends. We don't need this. We don't need to know this, right? Just give me a second. Let me complete this. Now then you'll definitely have a p-value. Yes, the software will definitely give you a p-value. Same rule for p-value. P has to be, so you decide on alpha. Alpha is decided. You know how to decide alpha from our previous example. Then we will get p-value. We get the p-value. And then we see if we reject null or accept null. We reject null or accept null. Is that clear? I'm not getting into the other details of F test. We don't need it. Right? Pardon? Degrees of freedom. Again, like I said, I'm not going into this here. I'm not getting into any of those concepts, how F test is derived and all that. T test I did because it is slightly important for me. You will understand why in future. F test, we will do an example and we will see how F test is used, but beyond that, let's not get into it. Right? Not required. It's not required for us to know, but it's required for us to know how F test looks like. Why F test? When, which situations you have to use F test, that's all. If you know that, that's more than enough. Now, Rajesh, please go ahead with your doubt.
Yeah, Suneet, regarding the measures of dispersion that we were talking about, in this case, we will be considering variance as well as the standard deviation, but then we'll be focusing more on variance as far as the F test is concerned.
Variance, yes, not standard deviation. I mean, like variance is taken as a standard for F test.
Okay, and what exactly?
Doesn't mean that I can't take standard deviation. I can take it. That's what I said.
Okay.
I can definitely tweak this. Which situations to tweak it and all, some of them you will come across it in future.
Okay,
Right?
fine. Yeah, fine. Okay.
Like, I'll just again give you a heads up to everyone. In regression, we come across something called global hypothesis or global hypothesis testing. Right? In that case, we'll come across F-test again. In that case, you will see a slightly tweaked definition of F-test. You will never see the word variance over there. You will see a hypothesized value called 0. So we'll all see that later, not now.
Okay, Sunil. Thank you.
No, Prerna, I think it is within by between.
I think
But
the
it is the
F-test
opposite. Did
value
I
is,
just write it the opposite way?
the F-test value is opposite, because if I remember, the P value is small, F value is large. So
Oh, okay. I think I have done a mistake here. I'm so sorry. Let me confirm that. Yes, what you're saying might make sense. Just give me a moment. And I'm guessing both of you guys are correct. Just give me a moment. Yeah. I'm so sorry. I stand corrected. Oh yes, usually between the groups, F value comes up to a bigger number. Yes, guys, please take this correction here. And yes, Uttam, you're correct. Like, higher the F value, more is the probability of rejecting the null hypothesis. Because if variance between the groups is too high and within the group is too less, both the things, right? If both the things are happening simultaneously, then F value will be the highest, right? If F value is the highest, then you are getting into your rejecting of null hypothesis. And the statement will be now dependent on your alternative one, right? Yeah, thanks, Prerna and Siddharth. Not Siddharth, I'm sorry, Uttam. Mute, please. Prerna, please mute yourself. All right. Okay. Next up, till now, what all we are saying is we had a group. We had these groups, which is categories, in other words. And we also had one continuous variable to look at, right? Sales, spend, right? These are all continuous variables to look at. Hence, we used to talk about the concepts of mean, median, or maybe variance in all the z-test, t-test, and your f-test. Now, let's say you have a situation where you have two categorical variables. You have got two categorical variables. And we try to check if one variable is influencing the other variable or not. So if I can give you an example like this, let's say there is salary bracket, yeah. So my salary bracket contains, let's say, 1, 2, 3, where 1 being the highest, 3 being the lowest, right? Or pay scale or salary bracket, whatever. Let's say I have educational qualification as one of the columns. And in here, let's say I have a grad, I have a post-grad, and I have a doctor, right? I have another variable, let's say region. A region, let's say I have north, south, east, and west. And let's say I use something called experience. Experience, I'll have let's say 0 to 2 as one bracket. Let's say I have 2 to 5 in another bracket. Let's say I have 5 to 10 and greater than 10. Let's say these are my brackets. And lastly, I have one more categorical variable. Let's say gender. Male and female. Now, let's look at this versus this one by one. Salary bracket versus educational qualification. In general terms, in business terms, do you think educational qualification affects salary bracket? How? The more you are qualified, the more salary you might get. So that's one assumption. Or region. Does it affect your salary? Online guys, Prerna, Uttam, Siddharth, Rajesh, do you think region affects my salary bracket? No. Does region affect your salary bracket? That's the question. Some say yes, some say no. Same goes for educational qualification. Most of you said yes, because more qualified you are, more salary you can get. Okay, let's debate that. Experience. Again, more the experience, more will be the salary. Very good. Gender. I wouldn't dare say this because still, let's say, guys, so sorry. Let's say females are getting more salary than males. Is it really affecting it? Okay.
It depends on industry to industry. Film industry does not apply.
Now let's look at the entire question one by one.
In IT industry, it does not apply. The education qualification that you apply is separate. In research, it applies.
Yeah. You have to go back home, right? You have to go out of this institution, right? So, all right. So yes, I'll come to those points again and again. Everyone said yes for this, but I might say no sometimes. I might say like, let's say somebody is a PhD from a state's university. Let's say somebody is a graduate from a premium college. They might get a good pay scale than a PhD that exists. Region, usually the cost of living in north, east and west is north and okay, the cost of living in west and south is a little bit higher than north and east. Bangalore is anyways costlier. Any day, on any given day, it is costlier than Delhi or Gurgaon. If you are making it alive in Gurgaon, right? Sorry, Gurgaon guys. Again, coming to experience, let's say again, a person might be having 2 to 5 years of experience. They might receive salary greater than someone who is falling under this bracket. Might be, right? And same with gender. Industry to industry, it varies, like sir said, right? You have to prove all these things. We can't simply keep on speaking, or we can't intuitively guess something, right? We have to have some data backing with this. We have our data, we have to prove it statistically, right? So this test is known as chi-square test. I-square test, right? So let's first build a cross tab, and everyone please look at this example. I'm building a cross tab of observed values or observed data points. So in my data, let's say I'm taking pay scale. I'm just doing that here in Excel. That's a little bit easier for me. Let's say I'm taking this pay scale here. 1, 2, and 3. And let's say I'm taking qualification, right? Qualification as grad PhD, PG, and PhD. Yeah. So I'm basically building a crosstab. So I'm just taking arbitrary values. Right? These are my observations. This is what my data is. And if I'm building a crosstab, I'm getting this one. I hope everybody understands what a crosstab is, right? Right? Okay. Fair enough. Now, we will be calculating something called chi-square value. Chi-square value. Right? So these are my observed. Right? Let's calculate something called expected values or expected data points or expected frequencies. These are my observed frequencies. Let's look at our expected frequencies. And what do you understand by expected frequencies? Let's see that. I'm just removing this and I want everyone to please pay attention. First of all, let's calculate our row sums and column sums. What is the column sum here? What is the row sum here? 70. Here 60 and here 55 and here it is, pardon? 80 here and pardon? Okay. Right, and overall it makes up 185. Here. So let me put it here like this. So these are my observed values. These are my row sums, column sums, right? Now, if out of 70 people, out of 185 people, that is, out of 185 people, 70 people come under pay scale 1. Is that correct? Can I say that? Out of 185, 70 fall under pay scale 1. Yes or no? Then out of 80 people, how many would fall under pay scale 1? That's my question. If out of 185, 70 people fall under pay scale 1, then out of 80 people, how many people would fall under pay scale 1? Why did I specifically take 80? Because 80 is the total number of graduates available in my data. Clear? So how do you calculate this one? Unitary method, I guess, right? So 70 divided by 150 overall into 80. Sorry, not 150, I'm so sorry. 185, I'm so sorry. 185. 70 into 185. 70 by 185 into 80. Yes or no? I hope everyone has understood this, what I have done here, right? Online guys, I hope we have understood what I have said this, right? Does it make sense? Yes? So let me add the value here. Is equals to, okay, 1 second. Here, for this, 60 into 80 by 185. Yes? Yes or no? So out of 185, 60 people fall under pay scale 2. Then out of 80, how many people will fall under pay scale 2? So 60 by 185 into how much? 30, right? Yes or no? Guys, wake up. Yeah. This one. Why 80? Why it should be 80? Exactly. So that's why I said wake up. Yes or no? Now, again, 55 out of 185 fall under pay scale 3. Then out of 80, how many people will fall under pay scale 3? 55 divided by 185 into 80 again. 40. 80. Very good, very good. Phew. Let's do it for this quickly. Come on, come on. Divided by? Whatever. Same thing only, no? It's a multiplication, right? Same thing. Stop behaving like standard 5 kids, man. Okay, so yeah, you are correct about it. 70 out of 185 into 70. How about this one? Next one? 60 by 185 into 70. How about this one? Yeah, go on. How much? 55 divided by 185 into 70. So equals to, and then equals to, and then equals to. Yeah, come on, tell me this one. 55 divided by 185, that's common. No. 70 by 185 multiplied by 35, yes. How much? 60, right? And then this is 55. Come on. Oh, sorry. Yeah, got this? And let's put it in this color. Whew. These are your expected values, right? Observed, expected. Is there any discrepancy between these two? Yes, there are. Apparently, there is a lot of discrepancy here. Now, what do we do with these two? Using these two, we will be calculating something called chi-square value. And the formula is here, observed minus expected by observed, I guess. Let me confirm that. Yes. Observed minus expected. Observed minus expected divided by expected. Right? I hope that's clear, that formula. So this is overall sum of, like sum of all the observed for all the values, right? That's your chi-squared value. Is that clear? Everyone? I hope everyone is able to understand what I have done here, right?
Sunit, can you please repeat that formula once again? Chi-square value?
So this formula is, see, you have got observed values, isn't it? 1 second. You have got your observed values, guys, isn't it? 10 is the observed value for this particular thing here. Yes or no? What is its corresponding expected value? 30. So what you do here, you do 10 minus 30. Sorry, yeah, 10 minus 30 divided by, please turn off your mic. Niskarsh, right? Plus next value 30. What is its? That's my observed. What is its corresponding expected value? 25. 25.9, let's say, right? Divided by 25.9 and so on. This is also not 30, this is 30.27. Likewise, you do it for all the 9 values, right? Sum up all the 9 values. That value, what you get is your chi-squared value. See, please look at this formula. Observed minus expected whole square. Okay, whole square. I forgot this whole square value. Oh, I'm so sorry. Observed minus expected whole square. Can anyone tell me why there is a whole square factor involved here? Exactly. So that positive and negative don't cancel out. Or I would take an absolute value, but in this formula I'll be looking for squared values. So observed minus expected whole square by expected. The overall sum. That's your chi-square value. Again, do I have to repeat it from the beginning? Whatever I have said. What is the situation? Can anyone tell me where did we begin with? What is your test actually? What are we trying to prove? Dependency of 2 categorical variables. What do we have here? We have a crosstab between those 2 categorical variables. I hope everyone understands what the crosstab is, right? So in this crosstab, what do you find here? We find your observed values. How did we calculate expected values? So I hope you have now understood the formula, right? And then we got our chi-square value, isn't it? So what do we have to do with this chi-square value now? What can we do with this chi-square value? Now, based on the degrees of freedom, based on the kind of inputs that we are giving, we have a chi-square table. So based on these inputs, we can find out something called critical chi-square, right? So I'm just writing that down. This is my calculated chi-square. There is something called critical chi-square, which depends on the sample size, alpha, degrees of freedom, and so on. So from the chi-square table, we will be calculating this critical chi-square value. Is that clear now? Yes? Chi-square versus critical chi-square. Now, if this chi-square tested value is greater than chi-square critical, so then we will go for accepting or rejecting null hypothesis based on if it is greater than or less than. If my calculated chi-square is greater than or less than the critical chi-square, we'll then decide what to do with our null and alternative hypothesis. Is that clear? How do you define your null and alternative hypothesis here? How do you choose your null and alternative hypothesis? So in non-mathematical form, I would say there is no such difference between these 2 groups, which means A and B are not influencing each other. That will be my null hypothesis. My alternative hypothesis is if one is getting in, the other changes. So there is a variation observed. There is a dependency observed. So that would be my alternative hypothesis. Is that clear? Then we will accept or reject that one, depending on the p-value. Again, I'm not going into details of chi-square test. Is that clear? Now, if you're wondering where do we use our ANOVA and chi-square, why it is so important, let me tell you. In linear and logistic regressions, we will be looking at continuous versus categorical variables respectively. In our regression problem, a continuous variable is the main variable here. In a classification problem, a categorical variable is the y variable or main variable. Now we are trying to prove how others are reacting to these variables. Are they directly involved with this variable? If yes, I'll consider those variables. If they are directly not involved with these variables, if they don't have much dependence on these variables, then I'll not consider those variables for my equation. I hope you're able to understand what I'm saying. So let me write that down here. The importance of ANOVA and chi-square. If I have a y variable in linear regression, for example, and I have a lot of x variables here, x1, x2, x3, and so on. These are the other columns of your data, that is. And this is your y variable which you're trying to hold. Now, if you want to see if x1, x2, x3, x4, x5, they're directly dependent on y or not. And let's say x1 is categorical, x2 is continuous, this is also continuous, this is categorical, and this is continuous. If I have to prove y is also continuous for a linear regression, if I have to prove that y and x1, which is categorical, are directly dependent on each other, what kind of test do you think I can do? Continuous and categorical. What kind of test can I do here? F-test. If I see this category, this categorical variable has more than two categories, more than three categories, three or more than three categories, I can simply go for a F-test, right? If x1 is not so dependent on y, if F-test is failing here, if F-test is failing here, and if F-test is passing here, then I'll not consider x1 for my equation. I'll only consider x4 for my equation. So this I'll not consider. This I might consider if my F-test is passing here. F-test pass here, F-test fails. I'm not considering x1, I'm considering x4 instead. Is that clear what I'm saying? Yes, this is where F-test is used in practical sense.
How do you define
One second, let me complete. This is the practical case where I'll be using F-test. Now, I'll ask you one question. How do you check x2, x3 and x5 which are continuous, whether they're dependent on y or not? How do you check it? Continuous. What do you calculate here? What do you calculate here? No, not t-test. T-test is like little bit on a higher note. Continuous. This is a very simple metric. Yes, t-test will go for it, but in a later phase. But in the first phase itself, to look at the dependency, correlation, simple. You look at correlations. Correlation matrix you look at. If the correlation magnitude is high, then yes, they are correlated. If the correlation magnitude is close to 0, they're not correlated at all, right? I hope that's clear, right? Now, yes, you can think about t-test, but that comes later. I mean, like, a simple correlation is enough to prove that, let's say, x2 is not dependent, but x3 and x5 are highly dependent on y. So I'll consider them. I'll ignore x2. Clear? Let's take example of logistic regression. Now, we don't understand yet what is linear and logistic, but I'm just giving you a perspective. In logistic regression also I have a same scenario. I have an exact similar scenario. The only problem is, the only difference in fact is, here y is categorical. Y is categorical. Now you have to prove if this categorical depends on this categorical or not. How do you do it? Chi-square, fantastic. Y versus x4, both are categorical, right? So we'll go for chi-square. And y versus x1, what do you do here in this case? Y is categorical, x2 is continuous. Categorical, continuous. What kind of test we can do here? An F-test, ANOVA. It's the other way around here. There in this case, x was categorical, y was continuous. Here y is categorical, x is continuous. What iota of difference does that make? Both are ANOVA or F-test, right? This is the practical sense where we will come across these tests again, right? Now, I think Rajesh was asking a question. Rajesh or Uttam? Please carry on with your question.
Yeah, I was asking the question.
Uttam,
I
please.
wanted to know how do you define failure or success of an F test? Because our null hypothesis was the variance is same across all the groups. That is of no value, right? Only if there's variance across the groups, like the Uber example you gave.
This one, right?
Yes, if F test fails, that was the null hypothesis is rejected.
No.
Then we consider F test to be.
One second. Uttam, 1 second. 1 second. Hold on, man. Hold on. When do you think F test will fail, guys? What do you understand by failure of F test?
You reject the null hypothesis.
And all the
No,
groups will
not
be
necessarily.
similar. When all the groups will be similar.
Think about it.
We will,
Not equal to UV.
So variance A not equal to B, not equal to C, then I say F test is good enough here, right? High F value. Yes or no? If the variances are not equal, come on guys, come out of your sleep, or do you need some coffee or something? If variances are high among the groups, what do you understand by that? Well, like that's a perfect scenario for F test, right? Does F test fail? No. F test is highly successful. I hope everyone is able to get this point online, guys, and Uttam. Everyone. Is everyone able to get this point here? Why did I say this?
Yes.
All of you?
Yes.
can you repeat your statement, Sunit?
Pardon?
Can you repeat your statement regarding the F value you said right now?
What did I just say? By the way, what did I just say? F test? When will F test value be high? When the variance will be high. High means unequal. Unequal variances between these three groups, which means my F value will go up. When the F value will go up, my F test is successful. So for F test to be successful, what do we have to do with null hypothesis? Reject, right? So, I mean, like, that's not the thing. The actual explanation is if null hypothesis is rejected, which means the variance of A, B, and C are high and different, and hence my F test is successful, isn't it? Yes or no? So, what do we do with null hypothesis? Reject. So, if while performing F test, if the P value is very low, what do we do with null hypothesis? P is low. Reject. So if we are rejecting P value, then what happens? Your null hypothesis is rejected, which means F test is success or failure? Success. Right? Now I hope everyone is able to understand this. Or should I write it down? Dear kindergarten kids. Just kidding. I hope everyone is able to understand this concept, right? So, null rejected, meaning variance is alternative is high. Variance is unequal, which implies F value will be high. Why F value will be high? Because you look at the formula, right? Between groups, by within groups. Hence, F test is passed. Is this clear to all of you online guys? Anand, Anil, Prerna, Tony, Viplav, Vishaka, is this clear to all? Uttam? Is this clear to you?
Yeah, Sunit, just one doubt.
Yes, yes.
In the below example, we are making a comparison between X and Y, right? And
Which one?
below one, no, between X and V1, this one, yeah, exactly. In the linear regression, we were making in comparison between X1 and X4, and we are telling if
Y and between Y and
between two categories. But then my question was that, like, for F test we should have at least three different or similar groups, right?
yes.
But we were mentioning just like we were making the comparison between x1 and y, something like that. Just for two groups, we were making in comparison. We were telling like f test pass and f test fail.
Oh, come on. This categorical variable might have more than 3 groups.
Okay. Okay.
Yes.
Okay.
That's the thing.
Okay, got it.
There will be one categorical variable with multiple groups, more than
Okay.
3 groups. That's what
Yeah.
it is.
Got it.
So if 2 groups are there, then we'll go for your independent sample t-test.
Fine. Fair enough.
ANOVA can't be applied in that case. The condition for ANOVA is 3 or more than 3. That's the basic condition. Yes, Santosh, please tell me what's your question.
Yeah, Sunit.
Yes, please.
Yeah, my question is, it's very easy to do chi-square test if we have one categorical variable, right?
Chi-square test itself is performed on 2 categorical variables.
Yeah, two categorical variables. Suppose I am doing any kind of logistic regression. I have a 50 number of my categorical variable is 50. I want to check which categorical variable is significant and which is not in one slot. How can we do that? I don't want to do 50 chi-square test. I want to do only one line of code. It may be a customized function so that I can able to
that's actually a very genuine question, everyone. But then the answer to that can wait for a while. Just to give you a heads up, Santosh, and to everyone who has listened to his question, if you have many number of variables, there are a lot of dimensionality reduction techniques available in stats. One of the most commonly used is principal component analysis, or sometimes we use something called factor analysis, right? Or hierarchical clustering of variables. There are a lot of variable reduction techniques available. We will employ some of those techniques. That we can discuss it later. Is that clear, Santosh?
Yeah, is it possible that you discuss this question today only?
Then I think we have to extend this class till evening 6 o'clock, where I'll first cover linear regression for 2 hours, and then 3 hours we'll discuss logistic regression, 2 hours on PCA. We'll do it till 6:30, shall we?
Okay,
Right.
okay.
So we'll discuss that later. All right. So these are about our tests. Let's take a quick 10 minutes break, right? And let's discuss a case study. Now, regarding this case study, I will be discussing each and every question. That will not be possible unless you also participate in that. I might tell you, the only thing that I'll be telling you is the code. What kind of test we will be doing, that is what you have to decide and tell me. So before you go to a break, just to give you a perspective on this case study, I'll not open it. I'll just explain it to you briefly. Please listen for 2 minutes. The situation is, I have got 200 customers. So sample of 200 customers I have got. How many? 200. Yes. So all are my credit card users. 200 credit card users. I have got their demographic information. That's common, like age, sex, region, segment, and so on. And I have some functional variables like card latest month, card spent. Let's say I'm looking for the month of October, or let's say I'm looking at month of September. I have the entire month's spent, right? That's the data that I'm having. Now the problem here is I have run a campaign. Run a campaign in near past. Not too long ago, like maybe like a couple of months ago, maybe I have run a campaign, right? And what I have here is post usage spent. What do you understand by this? Post campaign spent. Post campaign usage. Post campaign credit card usage. What do you understand by this? After the campaign. So I have got 2 things here. 1 month post campaign usage. 2nd month post campaign usage. I hope you're able to understand what all I have. First month post-campaign usage and second month post-campaign usage. Right? What do you think is missing? If I have these two, what do you think is missing here? What was my pre-campaign usage? This is the entire information I have. My first question here is to see if my campaign is successful or not. What do you understand whether campaign is successful or not? Let's talk about it later. I want to understand if males and females are spending equally, be it be post, pre, or whatever. I want to look at that. Let's see it later. I have something called segment, customer segment. Are the three segmented customers, there are three segments, are these people having same kind of trends or not? Right? Or I have a variable called region, and I'm just trying to prove if region is actually affecting what segment of customer one falls under. I hope you're able to understand what I'm saying, right? Is the campaign successful? Does male female have equal spend pattern? Does all segment people have same spend pattern? Does region really affect what segment a customer falls into? That's my next question. Lastly, I'll see has credit card usage improved compared to last year? We'll see all these things after a short break, right? It's 12 o'clock now. Let's take a break till 12:10.
Sunit?
Right?
Hello, Sunit?
Yes, please.
Sunit, I got disconnected in between, so if you can just leave your screen on Chi-Square.
Pardon?
My internet got disconnected. So just leave your screen on Chi-Square before going on break.
Leave. Okay. You want to look into the chi-square definitions?
Yeah. Just
This
leave
one?
your screen on. Yeah. Whenever you're leaving, just above. Yeah. Just leave your screen there whenever you.
All right.
Thank
No
you.
issues. I'll do that. Clear?
Yeah. Thank you.
All right. Guys, can you see my screen now? I mean, like, I hope it's frozen, but you're able to see it, right? Turn on your mic. Just tell me.
Yes.
All right. The